meaning the scientists could observe the collision on all spectrums, giving them a better understanding of the gravity theories than ever before. Ariel Levin-Waldman, I-24 News.
All right, we have a local scientist who could break down the meaning of these universal discoveries. Joining us now is Professor Zvi Piron-Schwartzman, Chair of Theoretical Physics at Hebrew University. Hello, welcome.
Hi, good afternoon.
Good afternoon. I want to say this is, I'm someone who also is very fascinated with the cosmos and studying a lot of Einstein's theories. It's very fascinating that this is, being discovered now. Like, what has allowed scientists to get this kind of information at this time?
Well, the breakthrough was the technological development of the two gravitational wave detectors, LIGO and Virgo, which were able to measure the gravitational waves. I mean, this was an incredible machine with incredible high precision, which is required to measure these tiny, tiny, tiny warps of space-time created by these gravitational waves. So it is unimaginable how tiny this influence is, and it took unimaginable, almost technological inventions to be able to measure them, and this was an investment of thousands of scientists to make this achievement. This is why it took so long. Actually, I never imagined that in my lifetime we will see this. I was too pessimistic.
Right, it's too, well, this is kind of the break between like the spiritual component and science. Einstein, I read books about him. I mean, he was truly a mystic, and he was fascinated by this. Like, what did he know then that we're only being able to prove now? Like, can you explain how he knew this stuff?
Well, Einstein's predictions were just based on mathematical development from his own equations. So he wrote down the equations of general relativity. He was convinced that the equations are correct. And then from the equations of general relativity, fairly simple analysis, which we teach in classes of general relativity, can show you that there must be gravitational waves. And Einstein believed in his theory, and therefore he was convinced that these gravitational waves should be there. I don't think he ever imagined that they would be measured.
What does this mean?
In his age and until his death, in his 50s, this was simply unimaginable.
Right. What do you, place, like I've been studying a lot, with the, Kabbalah, the cosmos, like the scientists then and the ancients kind of predicted this time would come, and I study a lot of different cosmologists that say we're at a time where we're going to make these discoveries. Does that resonate with you?
Well, I don't think that, I'm not sure I understood exactly the nature of your question. I don't think that people before Einstein could imagine that something like gravitational waves existed, because gravitational waves, the basic phenomena arises from this general theory of relativity. So without this theory, there was no reason to expect that anything like this would imagine. So I don't see how other people would have thought, or earlier people would have thought that such a phenomena could be there in nature.
What does this mean for the rest of us? I mean, so many people just think of E equals MC squared as like, I don't know what this means. So what does it mean, for people that don't understand the equation in practical terms?
For people, well, what does it mean? We are really on a realm of science which is getting farther and farther and farther from daily life. But there are two meanings of this that I can tell you right away. The first thing is that we all have these toys made of gold, rings or necklaces and so on. So finally we know where this gold came from. It came from such a collision. Not this particular collision that we saw today, but some collision like this happened in our galaxy, not far from our solar system, before the solar system was born, and the gold which was created there came to the Earth, came to the early solar system and merged with the material which formed the solar system. So this is the origin of gold, and not just gold, platinum, uranium, plutonium, all these exotic elements. This is the origin of these elements here. So this is just of interest.
Right.
An indirect result of all this research is the development of these gravitational wave detectors involves with numerous technological breakthrough which we don't understand their implication for, but I know that some scientists working on LIGO have already defected and left science to start startup companies using the technologies developed there for something completely different. So we may come up, I don't know exactly with what, but with new medical tools or new technologies which could be used in daily life, and they originated from this development of LIGO, just like some technologies came from space research which were developed for travel in space but are used now daily on Earth.
Right.
So this is another development. The biggest question, which we will not know in the next few years, is what is the implication of the gravitational wave. One day we may be able to use them like we use electromagnetic waves today, but this is really for the future.
Okay, thank you, Professor. I could talk about this for hours, but thank you, and I'm sure we'll have another discovery soon to interview you again.